Hey everybody, this is Mr. Munson, and we are in Unit 3 or G.3, parallel lines and transversals, and we're going to also deal with perpendicular lines, which you've probably had some experience in other classes, and we'll kind of fine-tune that experience in this lesson as well as some other lessons as we move along this year. This is concept number 2, so we'll call this G.3.2, parallel and perpendicular lines in the coordinate plane. So we're in the coordinate plane, we're talking X's and Y's. Let's go ahead and get started. Let's just do a quick review of slope. Now, if you remember, slope is rise over run. It's kind of the rise is going to be seen kind of as a Y idea, up and down, and the run is a left and right, which is kind of an X idea. So suppose we had some line, we'll call it AB, and I was looking for the slope of AB. So I would simply take the X's and Y's and put them in the slope formula. Now in this case I have a drawing, so I'm going to start there. I'm simply going to, the way I typically do is I go find which point is the lowest point of the points given, right? And of course A is the lowest point. So if I do it the same way every time, it kind of always works out for me. Okay? So I'm going to go and find the lowest point. B is certainly higher on the X and Y. So I'm going to start there. So I start counting up. Let's see, 1, 2, 3 until I'm level with the other point. That's up 3. Now the next direction is to the left. 1, 2, 3, 4, 5, 6. So that was to the left, so we'll call that -6. So the slope here is y is on top, -6. I'm sorry, rise over run. So we'll put the 3 on top. 3 over -6. I'm going to reduce that. I'm just going to bring the negative out front since there's only one of them, and I'll reduce that 3/6 to 1/2. So my slope here is 1/2, up 1 over 2. Then I get back to my line, and that does work. Look, if I start here, I go up 1 over 2, and I get to my line again. Okay, now let's look at doing this as a coordinate problem. So I look at the picture and I either get the coordinates off the picture or I simply am given only the coordinates. So suppose you didn't have a picture and all you had is these, and I asked you, what is the slope of the line AB? So I would use the slope formula. The slope formula is you take the y's and subtract them, and the x's and subtract them. So use all x's on the bottom. All x's on the bottom, and I just plug the points in. So the slope here is y's on the top, so -2 minus 1, and the x's on the bottom, 3 minus the -3, and that gives me a -3 on top, and a minus of a -3 gives me an addition, so it's 3 plus 3, which is 6. As you can see from the work above, I can reduce that to -1/2. They both work, and you should have them both in your tool belt because depending on the problem depends on which one you're going to use. Either the slope formula or go over to the X and Y and count up and over. Okay? Now I have a statement here. Two lines are parallel. Okay, so that's the word parallel if you need to put that in your notes. That's the symbol for it. Two lines are parallel if and only if they have the same slope. So if we're trying to compare two lines and figure out which one has, if they're parallel or not, we just simply have to look at their slopes and determine if they're the same. If they're both the same fractional slopes, they're parallel. Now, over as a different idea, we have two lines are perpendicular if and only if their slopes are opposite reciprocals. Two words, two ideas. Let's briefly talk about what that is. Make sure you put this in your notes so that you can come back. All right, suppose I'm given a slope of 3/5, and I want to find a slope that's perpendicular to it. The opposite reciprocal means I'm going to look at the sign of the original slope. In this case, it's positive, and I'm going to make the other one negative. That's the opposite part, right? Change the sign. Now, the second part is reciprocal, okay? And whatever that means. So let me tell you what that means. That means take the fraction 3/5 and turn it upside down. That's the opposite reciprocal. So now this slope right here is the slope that's perpendicular to 3/5. Okay, reciprocal. Let's just look at what this means, okay? So if I have a slope that's equal to a over b, whatever the numbers those are, the perpendicular slope is going to be opposite b over a, okay? So this is what you want to know. When you're looking at slopes that are perpendicular, one is always positive and one is always negative. That makes them opposite. All right, let's look at the picture over to the right. You need to know that a line that is drawn like this, where if an airplane, let's say, was coming from the left, we read left to right, airplane's coming this way, and it hits it and starts to go up, we know that's a positive slope, okay? All right, so let's look at this. Now, we're going to be having to write equations like this through this video, and so stay with me. We have to remember what these equations represent, okay? So if you remember back in algebra, we had this form, y equals mx plus b. Now, we already know the m is the slope. We just talked about that, okay? And the b is where it crosses the y-axis. This is called the y-intercept, okay? All right, so I can see on this equation right here that this is I'm looking for a slope of 3/5, and it crosses at -3. Now, our line here does cross at -3. Let's see if it has a slope of 3/5. 1, 2, 3. I just counted up. Then 1, 2, 3, 4, 5. Indeed, that is a slope of 3/5. So that's the line drawn of this form, okay? Make sure you understand that before you go any further. All right, now according to what we just talked about with the perpendicular, if I wanted to write an equation that was perpendicular to that, then all I would have to do is look at this slope and write its opposite reciprocal. Just stop for a second, and someplace on your paper, we'll write 3/5. Write what you think the opposite reciprocal or the perpendicular slope would be of that. Put me on pause and come back and check your work. Well, you should have had -5/3. Okay, let's continue on. I'm going to go back over to the picture to the right, or to the left, and I'm just going to put it down a random point. This looks like a good point right here. Now what I'm going to do is I'm going to take that -3/5 slope that I just found was perpendicular, and I'm going to go find another point. So going to this random point, I'm going to go up 5. Let's put it down. Let's put it right here. This would be a good place. Let's go up 5. 1, 2, 3, 4, 5. And then I have a negative, so I need to go in the left direction, 3. 1, 2, 3. That will create a negative slope. Now look what happens. I have a line that's perpendicular to the previous line. All right, let's take a look at this drawing over here to the right. Now the directions is asking me to write an equation of a line that is given there. Okay, now to do this, I'm going to need some important information to write the equation y equals mx plus b. I'm going to need the slope. All right, sorry for that interruption. I'll need, in order to write this equation, I'll need to know what m is, the slope of the line, and I'll need to know what the y-intercept is. Sometimes when we look at the line, we can tell. In this particular one, I can kind of see it's someplace just above 2. Now, we're going to come up with a process for doing this, but what I need you to know is these are the two main ideas. We need to have the slope and the b. All right, let's look at some problems now. Now, I'm going to have you do problems on your do-it problems that are going to mimic what we're doing here. Now, we won't have as much time for you to do try-it problems. I'm going to do the example problems, and you're going to need to make sure you're taking good notes so that you can refer back to them during your do-it problems times, okay? So make sure you're taking good notes. Here's one of the I can statements that says I can write the equation given a point on a line and the slope. Okay, so basically what this is asking is for me to find a line and write the equation on that line that goes through that point A, and that has a parallel or has a slope of -4/5. Now I can draw that. That's no problem. I just simply, let's say, go up 4, 1, 2, 3, 4, and I need a negative slope, so I'll just move to the left 5. 1, 2, 3, 4, 5. And so here is the picture of the line that I need, but it doesn't tell me the equation of the line. All right, going back to, I need to know the slope. These are my needs, right? I need to know slope, and I need to have the y-intercept. Okay, take good notes now. All right, well, the slope is already given to me. So what I'm going to do is I'm going to write mx plus b. Then I'm going to substitute the slope into the equation, -4/5 x plus b. Now what I'm going to do next is I'm going to bring the point that they gave me, in this case 4, -3, and I'm going to put it into the equation and force everything to fit around that point. Okay, so what I'm going to do is I'm going to take the -3 and I'm going to plug it in for y, of course, and then I have 4/5, -4/5 times 4, that's the x, plus the b. Now take a look at my equation. I have one unknown in this equation. Everything's been filled in. I have one unknown, the b, and now I can go and find the b. Now I've just found that it's a little bit easier in this case. Go ahead and take -16/5 and turn it into a decimal. It doesn't turn into a crazy decimal, so it's easy for me to write. And then I'm just going to simply solve for that b. I'll add 3.2 to both sides, and I'll use my calculator if needed to find out what the b is. It's that simple. And there I have it. I have my b. So my slope was given to me. I just needed to find out how to do my b. And so I plugged in my x's and my y's. I got it. So now I can write the equation. Y equals -4/5 x plus 0.2. And that's the equation of that line. It's that simple. Oh, I love these problems. You know, it looks hard. A lot of students make mistakes on it, but it's the easiest problem. When you see these on tests, you should celebrate. This is so easy. So it says I can draw a line parallel to another line through a given point. So as you can see, I have a line there, a red one, right? And so that red line has a slope. So what I need to do is I need to take that slope, whatever this is, and I know how to calculate that. I've already talked about that. And I'll put it onto that point. So let's start. Let's just start at the lowest point again and count up. 1, 2, so that's a slope of 2 so far. Rise is 2. 1, so going from this point, we're going to go 1, 2, 3, 4. So it's up 2 over 4. Well, I could do that. That's no problem. I can reduce it to 1/2 if I want to. So I go up to my blue A point right here. And just kind of fix this real quick. So I'm going to go to that blue A point, and I'm going to go up to 1, 2, and over 4. 1, 2, 3, 4. And there I have a line. Now I could have done up 1 over 2, and that would have given me the same line. Use a straight edge. I get myself a pair of parallel lines. It's that simple. I love it when those problems are given me on tests. They're so easy. All right, so now it's saying I can write an equation of a line parallel to another line through a given point. Now we just talked about how to write an equation. You know, we have to have the slope and the y-intercept. Okay, so what we're going to do is first of all find the slope of the red line. Since it's in picture form, I'm just going to simply count up and then over. Sometimes the slope's given to us, sometimes we have to find it. Now let's do the find b. If you remember, I wrote down the equation standard form. Now let's put the slope into it. And then I took the point, I wanted to run the line through, that one right there. In this case, it's 1, 2. And I'm going to plug it into the equation to find out what the b is. And there it is. I have an equation with an unknown b, so solve for that. Subtract 1/2 from both sides. And I have myself an equation. All right, so if I wanted to, we could just simply use this slope to go up 1 over 2. And I can just double check it. I'll slam it through there. And if you look, it does look like it goes through the y. Remember, that's your y-intercept, around 1.5. Oh, prove two lines are parallel. That's super easy. Let's see if we can ask the question first. So I have these two lines, L and T. A couple of points that are on L are A and B, and a couple of points on the line T are C and D. So here's the question. Is L and T parallel? So now it's just a matter of finding the slopes of those two lines and comparing them. Go ahead and put me on pause. Use the the slope formula to find the slope of each one of those, and then compare those fractions to see if they're the same. Okay, as you can see, I went and calculated the slopes for each one of them. Since they both had a negative, and one on top and one on the bottom, I just simply got rid of the two negatives because they cancel each other out. So I end up with two positive slopes, 6/5. Then I write, hey, the two lines are parallel because the slopes are the same. So now that I have to ask, are these two lines perpendicular looking over to the left? Now I could care less about anything other than this number and this number. I'm just going to look at those numbers, 3/5 and -5/3. And I'm looking to see if those are opposite reciprocals. Well, first of all, it meets the opposite part of that because one's positive and one's negative. Do they meet the reciprocal part? Well, yeah, because it's 3/5 and the other one's 5/3. So that meets. So yes, these two lines are perpendicular. Okay, so here's a question. Are the lines AB and CD perpendicular? To do that, again, I'm going to look at their slopes and see if they're opposite reciprocals. This time it's using the slope formula. So I'm going to have you do that work and then come back and check it with me and see if you got it right. Put me on pause, go check the slopes and see if they're opposite reciprocals. If not, then they're not perpendicular. Okay, there's my math. Now notice that I write an M with a little subscript of AB. I need you to do that so that I can clearly see which slope you're working on. And the previous problem, I put a T and an L down there. Okay? All right, well, I found one to be -2/3 and one to be 2/3. They're opposites, but they're not reciprocals. They have to be both, okay? So no, these are not perpendicular. They are opposites, but not reciprocals. Okay? All right, pretty much last hit. Draw a line that's perpendicular to a given line. I love these. These are so easy. To do this, I'm going to have to find the slope of the original line, T. I'm going to do the opposite reciprocal and then apply it to the point that they need the perpendicular to go through. So find the slope of T. I'll put up the points for you so you can see them if you're having a hard time seeing it on the graph. So find the slope given A and B, and then apply it to the point 2, 1. All right, put me on pause, come back and check your work. Now I calculated slope to be 3/4, a positive, and that makes sense because that's a positive line. Now I'm just going to quickly run up using the picture to see if that's true. Let's see, I'm going to start at the lowest point here at A and go up 1, 2, 3, that's a 3, and then 1, 2, 3, 4, 5. Since it's in the right direction, I have a positive 3/5. Now I'm going to go and apply that slope to the other point. So go find that other point. In this case, it's green. So I'm going to go up 3. 1, 2, 3. Whoops. I need to find the perpendicular slope, don't I? The perpendicular slope is going to be opposite reciprocal, in this case 4/3, negative. So I'll start at the green one. I'm going to go up 4. 1, 2, 3, 4. I need a negative slope, so I'll go in the left direction 3. 1, 2, 3. And there is my perpendicular slope. All right, go ahead and write up your summary. We're getting ready to go over to the do it problems. We only have 2 sections in this unit, and so the videos are a little bit longer. The cool thing is you have a lot less videos to watch, and so we'll be through this unit pretty quick. All right, I'm going to go to the do it problems. I'll zoom in on them so you can see what they look like and maybe chat a little bit about them first. Okay, there you have it. Let me zoom in so you can see them. All right, remember, if you don't have your work, then I can't give you credit. That's just the way I'm getting harder and harder on this. Some of you are spending way too much time on the video to get not 100%. Some of you are just simply watching it and not necessarily taking notes or taking it seriously, and that's just going to keep on chipping away at your grade and your knowledge, and you're going to start falling behind. I don't want that for you. You do what you need to do, though, in order to survive this class. I think the best thing to do is take the class seriously right from the very beginning. All right, so no work, no credit. You must have the original information, okay? That means all this blue is on your paper. All right, for the first couple of problems, 1 and 2, and then problem number 5 at the end, we're using these points A and B. Find the slope of A and B, and then find the slope that's perpendicular to A and B. Make sure you write a sentence for number 2 of why you believe that's the slope. All right, number 3, look at the following 4 equations and determine which 2 are parallel, and then write a sentence why you believe this. Number 4, in those same 4 equations above, which of the 2 are perpendicular, and then state the reason why. And then number 5. Number 5 is a review question. Find the length of the segment AB using the A and B at the top of the page. This is a distance formula problem. All right, have a good one. We'll see you next time.